Says triangle is in the shape of 30, 60, 90 right triangle. The hypotenuse of the outer edge is 37 feet. Find the lengths of the legs of the triangle. If we look at that, does it ever say anything about that inner triangle? No, and I don't know the purpose of this. But this is just so if I'm not looking at that thing right there, I don't know if you can see it, but this says this is 37. Here's my 30-degree angle up there, 60 degrees down here. Isn't across from my right angle, isn't that 2n? Always in a 30, 60, 90 right triangle, right? Across from this side is n, so how do I go from 2n equals 37 to just n? Okay, so that gives me 37 over 2. All right, now I'm leaving my answers as exact answers because look down here, it says simplify your answers, type an integer or simplified fraction, type exact answers with radicals as needed. So I can't type that, I can't say that's 16.5, or sorry, what would it be? Huh? Yeah, I'm going to have to change it to inches here in a little bit, but I can't say that that is 18.5. Okay, does that make sense to everybody? They would not accept that. So then over here, this is going to be 37 over 2 radical 3, right? Okay. Now, those are in units of feet. Okay, so we did this in the last class, and people were typing that, and you did it wrong, you did it wrong. Well, we found the length in feet answer the question. The question says inches, right? So if this is in feet, it's 37 over 2 feet. What do I need to do to get that into inches? Yeah. For every 1 foot, there's 12 inches, right? Does that 2 and the 12 cancel to give me 6? So can I put whatever 37 times 6 is in there? Okay. Now, the reason I like this question is because they make you do it this way too. 37 radical 3 over 2. That's in feet right there. You multiply that by 12 inches over 1 foot. I get that. Now the 37 and the 6 are what we need to multiply together, so you'll figure out what that is, 37 times 6, and then times radical 3. Is that right? And then those would be your exact answers that you need to type in. I think the reason, so if we were to go back into the way the question's programmed, I think they've got it set up to where everybody gets an odd number here. Or most of the time you get an odd number based off of their coding. And it's in feet, so I would answer this as 37 over 2. This is 37 over 2 radical 3. But the reason I think they ask you to convert it into inches, isn't anything over 2 times 12 going to give me a whole number? Yeah, okay. So the reason they ask you to convert into inches is so that you can present a number like that without a fraction, okay? But that is, we're going to be doing conversions quite a bit in this course. We're going to be doing this stuff of leaving answers with radicals in them. It's just something we have to develop a proficiency with and an understanding of. Today we're talking about some of the other rules of radicals, how to add them and subtract them and that kind of stuff. Is that all right? Again, I don't know why they put that little inside triangle in there. It's just pointless, I guess. Trey.
So the shortest side would be
It'd be side, yeah, it'd be that side right there, 37 over 2.
How many inches that is?
Yes.
You just use that in front of the square root of 3 and get your answer.
Yes. Yes. Everyone understand that? So he's saying, well, if I were so I got this in feet, if I convert that over to inches, once I have that number, can I just put radical 3 in front of that to get that in inches? Absolutely, that'll work. Okay, it maybe saves you one conversion process. This one? All right, let's see here. All right, so this question, last class we had a 10 there. This one I pull off is going to be a 25. It's nice if that number is even, like 10, but 20, we'll do it with 25. See here, Control C, V, V. All right. So what I'm doing here is just going to kind of redraw my picture because I think it's going to be kind of essential for us to recognize this. I'm going to leave this one alone. So this is the original. Okay. Now, when I look at the original one, they asked me two questions. The first question is, how long is longest brace? Which, if we think about it, look at the picture, the longest brace is going to be that distance right there, correct?
Yep.
Okay. The second question then will be, if we read it, and I want to bring it so I phrase it correctly. I'm going to have to show the completed problem to get that second question. So here it says, how much higher does the longer brace reach than the shorter brace? How much higher? So it's about how much higher on the building. Okay? I think a lot of people earlier in the day were taking that distance and that distance and subtracting them. But that doesn't tell me how much higher they reach from the building, right? That tells me how much longer the purple one is than the blue one, right? What we need to be able to do and to answer question B is that we're taking that distance and that distance, and what do I do with those to find out how much higher the blue one is? Subtract them, okay? So that's what we're going to be doing, okay? Now, this type of question, you hear me say this with a lot of them, they're sometimes they're like puzzles or brain teasers sometimes with questions like these. I want to look real quick because some people want to address finding the length of this longer brace instantaneously. So the only way I can do that is to focus on the 30, 60, 90 triangle, correct? If I focus on the 30, 60, 90 triangle, do you have any values off the 30, 60, 90 triangle that allow you to move around that triangle? No. Okay, so the special right triangle stuff was geared for getting us to be able to take one value off of that triangle, one distance, and allow that then to create the other two distances, right? Well, I don't have that here. I have no distances to do that with. So I can't use that triangle, but the value that I do have matches up for that triangle there, doesn't it? Does that make sense to everybody? Now, if I put my template of I take a 45, 45, 90 triangle and I lay it on top of this one that has just the ends, and n radical 2. Won't this be n, this side be n, and this side be n radical 2? Now, does it make sense that that side, if I put my template on top of it, that's my equation? 25 equals n radical 2. Okay, so I'm going to divide by radical 2. And then I'll rationalize that. So we get 25 radical 2 over 2. The reason it works nice with a even number is because that 25 and the 2 is an even number. Say that 25 is a 26. It'd just go down to 13 radical 2, right? Sam?
Can you time it by radical 2 over radical 2 because you can't have radical 1 on
Yes. So that's a good question. So the reason I multiply by radical 2 over radical 2 is for that process of called rationalizing the denominator. We don't like to have a radical in the bottom. If we go through the problem and I look at the way that question A was worded in regards to how they want me to type it in, they say type it in the nearest tenth, right? I'm always going to, in class, work the problems out so that we get an exact value when it's appropriate, when the values are, when it's possible, okay? And this is a situation where it's possible because if I say I'm only going to work with values according to the directions, so they say 10th place or whatever, then I don't get the practice of simplifying radicals that we need to practice with. Does that make sense? If I can get the exact answer by practicing these simplified radicals, then all I got to do when I want the 10th place is type that simplified radical into my calculator, and I automatically have the 10th place. And I'd have the 100th place, 1000th place, any place that I want. Okay? So I'm always going to do the problems that way, even though it's contrary to the way this question is designed. It still allows us to get to the right answer. So I get 25 radical 2 over 2. The next thing I'm going to do is now look at n, because that's what we solved for, right? N was 25 radical 2 over 2. So that is this side length right here, 25 radical 2 over 2. Okay? If I look at these two triangles back in the original, don't they both share that distance right there? So that distance is the 25 radical 2 over 2 and the 45, 45, 90. If I come over here, the reason we have this triangle over here is because I'm going to now look at that triangle. Well, if I'm going to look at that triangle, we now know that this distance here is 25 radical 2 over 2. That angle there is 60, right? In a 30, 60, 90 triangle, what is the side across from 30 always going to be called n? What's the hypotenuse always called? 2 times n. Okay? And then this side over here is always going to be n radical 3. Okay? So right now I've got n, right? So doesn't that mean that 2n would be 25 radical 2 over 2 times 2? What happens to the 2 up top and 2 on the bottom? Cancel out. So I get the length here that they're asking for in part A to be 25 radical 2 meters. Okay? Now they ask you to type that in the nearest tenth, so I would take my calculator, type that in, and then round that accordingly to the 10th place. The next part of the question is how far do these two, or how far does that longer brace reach on the building in comparison to the shorter brace? So that's the longer brace, that's the shorter. So if we kind of come down here, the shorter one is what that n value was here, right? So that shorter one is 25 root 2 over 2. The purple one would be this distance here, which would be, we haven't figured it out yet, but it would be that number there times what? Radical 3. So to find that purple distance, I'm going to take 25 radical 2 over 2 and multiply by radical 3. You guys remember how to multiply radicals like that? What am I going to get up top? 25 radical 6 over 2. There's the length of the purple. There's the length of the blue. What do I need to do with those to get that distance here that would be the length that the higher or the longer brace reaches the, I guess the way it's phrased, and how much higher that longer brace reaches on the building? What do I do with those two values? Subtract the, what? Say again?
Well, you subtract the purple one by the blue one.
So purple one first, right?
Yeah.
Okay.
Purple one goes.
So I'm going to go 25 radical 6 over 2 minus 25 radical 2 over 2, right? Okay. Now, what happens there, guys, is that those numbers are not like radicals, so you cannot do the subtraction. Okay. That's the exact answer right there, and that's the best way we can leave it. Okay. If we want to put it all over 2, we go 25 radical 6 minus 25 radical 2 all over 2. That's fine as the exact answer. If I want to type it into my calculator, type it in that way, hit enter, and you can round it into the according or the specific decimal they asked for.
How did you get the length of the longest brace?
We found that in. So we're looking here, right? We had to look at this special, or this 45, 45, 90 first, and that gave us this distance here, correct? Well, that red distance is the same as the red distance over here in the 30, 60, 90, correct?
Yeah.
So we transfer that value. If that's in the 30, 60, 90, then we double that value to get the hypotenuse, which is a longer brace. And that gives us 25 radical 2.
32.5 millimeters.
Huh? Well, you got, so you typed in 23 square root 2. See, they want it as a decimal when you're typing it in as a radical.
Come on, you got me.
Email me and remind me. There is a little bit of a weird twist with this question sometimes, and it's because of rounding. If you answer that last part, somebody in the last class was getting this. They did everything right. They got like 9.8 as an answer, and it said back that no, 9.9 is the answer. And the reason for that is that the way the author was doing the problem is that they were rounding. So what they did is they took 25 radical 6 over 2, got that, rounded it. Took 25 radical 2 over 2, got that, rounded it, then subtracted those rounded values. And that's the stupidest thing ever, okay? Because now you're just compounding rounding errors. Does that make sense? So in regards to understanding kind of our reasoning for dealing with exact answers, I want you guys to be able to take from this class. Some of you are going to go in other areas. Okay? Some of you are going into manufacturing. Some of you go into sciences. Some of you might go into the medical field, stuff like that. You're going to maybe be dealing with calculations at some point, and you don't want to just start haphazardly rounding things, right? You got to have an understanding of, if I'm going to round values, and I need to do that a minimal amount of time, and I need to do it to where it minimizes the amount of error that I have, right? Speaking in our course in regards to doing that, if I can round the latest spot possible in my question, that's when I'm going to do it, okay? And rounding here, once I have the exact answer, rounding that exact answer is that latest point in time in which I can round. Does that make sense? Okay, if I were to take the 25 radical 2 over 2 right away and round that, because that number eventually gets doubled, and then that number eventually gets multiplied by radical 3, if I would have rounded it early on, then those two numbers are really off. Does that make sense? So understanding how rounding error is impacted, how it's compounded, based on when I round and how I round is very, very influential and very, very important for other courses and other just areas in general of career fields that you guys might go into. Does that answer that question? You had it. Oh, so you're saying on the wall? So the shorter the distance on the wall of that shorter brace is the same as the distance along the ground. So this distance here, what number do you have right there? 23. You have 23. So your distance here is 23 radical 2 over 2, is it not? Yeah. Okay. So what is that distance? Same thing. Okay. This distance here ends up being that number times radical 3 because of the fact that it's the radical 3 side of a 30, 60, 90 triangle. So your black distance here should be 23 radical 6 over 2, right?
I have it all written down.
Okay. So just subtract those.
I tried. It's not working.
Let me see here. Okay, so using our calculator sometimes because of the functions, and I don't have, my computer is messed up with my TI-83 or TI-84. And I don't know how to fix it right now, but if I was to jump on Desmos real quick, and this is the important thing to understand about the calculator that you're using. We have 23 radical 2 over 2. See how I do that? Is that really what I wanted? No. But if I'm doing this on a TI-83 or 84, I might type it that way and not know that I typed it that way. Does that make sense? Desmos does this, we call it kind of syntax, or shows you the real way that I really wanted to write that, correct? Does that make sense? And then the other one was Okay, so now I'm going to have these backwards. But that's okay, as long as I know that they're backwards. And I get that number right there, 11.9, right? Because it's backwards, it's negative. We're trying to find distance. Distance has to be a positive number, right? So if I take the absolute value of that, it'd be 11.9. So that's what you're looking for. If you can't get 11.9 mimic then on your TIE 3 or 4, then you've got some parentheses messed up.
I forgot to put the parentheses.
Okay, good. All right, so you got to figure it out. I will try to get my TIA 3A4 fixed on my laptop over the weekend, and then I'll show you that kind of stuff. Maybe not on Monday, but at some point over the next couple of days, kind of understand the tool that I'm using. Figure this, or think about this. If for some reason I need a wheelchair or something like that, or a motorized wheelchair, and have you seen any of those like new motorized wheelchairs? I mean, they're real elaborate, and they've got controls on them and all that kind of stuff, right? If nobody shows me how to use that device, that machine, can I use it correctly?
You could.
Could I use it correctly and efficiently? I mean, you can all use your you can turn your calculator on and start pushing buttons on it, right? I can turn the wheelchair on and start pushing buttons on it, right? But am I going to get where I need to go efficiently? Probably not right away, correct? It's the same thing with the calculator. If I don't know how my calculator operates and how it works and how the functions on it exist, then I'm not going to be able to use it to my advantage, okay? You've seen people like get injured with like one leg and then they give them one crutch, but then the therapist never tells them like what arm to put that crutch under, and they're always then putting weight on that hurt leg. You've seen people do that before, okay? Well, if the therapist tells me then how I have to use that one crutch and where I put it and how I put weight and stuff like that, now I can use it to my advantage, correct? Okay? So it's the same thing with your calculator. If you know how it works, you can use it to your advantage. If you don't know how it works, it's pointless in having, okay? It's like using one crutch and then putting all my weight on that bad leg. It's not helping me, right? Does that make sense to everybody? So understand, no matter what tool you have, and that's what kind of stinks about math, is because you might pick up a TI-83 today and try to learn it and use it. Tomorrow you might pick up a TI-30 and try to do your work with that. Well, it's programmed differently. And then you might get a Casio and then the next class, and it's programmed differently. And then we go to Desmos, and you got a different program, okay? That's been, for me, in regards to teaching, one of the harder things because, you know, I have to teach myself different calculators all the time because technology changes. There's not classes in schools for that. I learn how to use Desmos and GeoGebra. I teach myself that. And those are things that hopefully you guys are starting to recognize and pick up on a little bit as you are working with your TI-83s or A4s or whether you use GeoGebra or Desmos. There's ins and outs of all those little programs. And that's becoming because of the technology. That wasn't the case 25 years ago because there wasn't technology like that, right? Everybody did everything by hand, okay? And your technology was like this calculator here, but worse, okay? You just had like the 0 through 9 and a plus, minus, subtract, and multiply. That's all they had. Miss Coles, you asked Miss Coles, she had one of those abacuses. Okay, now that's a little bit extreme, but they didn't have calculators when she was in high school, so they used charts and stuff like that. So you got to learn different technology, and as you guys are getting older, and the way society is changing, and how technology is becoming very pervasive in society, you're going to have to learn those systems and be able to learn one, and then in 2 years, when that one's obsolete, you learn the new one, right? When you get in your jobs, the systems that you use in those jobs when you go through college are going to be completely different when you get hired 4 years later. Does that make sense? So you got to be able to learn and adapt and figure those things out. Question number 8, I think, has been a question of topic. Nope, not 8. 6.
Easy. Oh, can I teach it? I even showed you that I knew how to do that. No, I said, isn't that the right thing? You said, oh, yeah. If you let him do it, can I videotape it, please? No. Why not?
Did you guys understand the chopsticks question?
Yeah.
Okay.
Oh, yeah, I remember that one.
So if we talk about that one, I talk about that one as well. That's kind of what we're going to do. Obviously, the period's almost over. We have 13 minutes. Just talking about these types of questions. I think this is a common question I'm going to give you because think about this. This kind of relates back to, I put last class this as well. If I'm an author for an end-of-course exam, I want to be able to give you a test with minimal questions but then gain the most data from you. Okay? So I want to be able to know, and I want to be able to say I got this list of standards that you guys have to tell me that you're proficient in. And maybe there's 40 things on there. I don't want to have to give you 40 separate questions, right? If I can target those 40 standards in 15 questions, that's a better thing for me as a writer of a test to be able to do, because it does several things. One, it makes that test shorter, makes me have to write less questions. But two, it proves to me that if you are proficient in some of those things, you know how they tie together. Because if I'm asking you 15 questions that target 14 or 40 standards, then some of those questions are targeting multiple things at once, right? And you're seeing the tie-in. So here, this question targets two things. Do you understand how to deal with 30, 60, 90 triangles? And do you understand how to deal with 45, 45, 90 triangles? At the same time, it shows me that you understand maybe some creativity and how to address this problem initially, okay? You have some problem-solving skills, I guess, is maybe a better way of phrasing that. So I can target two things by you answering one question. Does that make sense? So these are the types of questions you might see on the end of course exam. Now, in the fact that you get it wrong, it doesn't provide me any data about you other than that you're bad at this, right?
Well, I wouldn't get it wrong.
Okay, it would not tell me whether you're good at 30, 60, 90s but bad at 45, or bad at 30, 60, 90s and good at 45. It would just tell me collectively the answer was wrong. You just got it wrong. Okay, I don't know which one of these. Maybe you're bad at both, or maybe you're bad at just one set of triangles. But if you get them both right, if you get everything right, it tells me you've mastered 30, 60, 90s and 45, 45, 90s, right? So in your mental approach for those tests at the end of the year, that's kind of what we want to start thinking about. They're going to start giving us questions that they're not just saying, okay, here's a right triangle, do the Pythagorean theorem. They're going to give you multiple things that stack on top of one another. So maybe using the Pythagorean theorem with maybe means, geometric means, with maybe special right triangles. Okay? Or maybe we use special right triangles to help find an area or something like that. Okay? So hopefully open your eyes to that type of things you're going to see on those tests will help you prepare for it a little bit mentally. With this question, I want to color these two triangles so I can talk about them a little bit easier. This triangle over here, the blue triangle, okay, what kind of triangle is it? 30, 60, 90. Do you know just by looking just at the blue triangle, so this problem started off without the white triangle on the left. Do you know any values or any side lengths of that blue triangle?
No.
No, so there's no way that you can move around that figure and create known distances, right? So in regards to trying to start this problem, a lot of people see that triangle on the right for some reason and they think, I got to find A right away, and I get in that triangle, I look at that triangle, and I can't do it, so I'm stuck. I don't know what to do, okay? It's like emptying a puzzle out on the floor. You take two pieces, the first two pieces out of a 1,000-piece puzzle, and they don't fit together. I don't know how to do it. You give up, you put it back in the box and go home?
Yes.
No, you don't. You pick up two other pieces and try to put them together, right?
No.
So if the first approach doesn't work, try something different. So let's look at the other triangle, okay? The other triangle, and the suggestion to you is, if you're putting a puzzle together, what do 90% of people do when they're putting a puzzle together? What is the first thing they do?
They do the outside.
They do the border, right?
Yes.
Okay. They do something that there's a you got those straight edges, right? There's a signifying characteristic or something that allows you to know where those pieces kind of have an idea of where they go, right?
Yep.
Same thing here. You look at the picture and say, where should I start with these things? Start where you know the most about something, okay? You start a puzzle around the border because you know the most about those pieces. They're border pieces, okay? So where am I going to start? I'm going to start in the triangle that I know the most about. Start in triangle on the left, okay? So 45, 45, 90. If we were to draw our template of a 45, 45, 90, sides are always n, right? Hypotenuse is always n radical 2, correct? If I were to overlay my template on top of the white triangle, what equation is generated? Okay, 7 radical 2 is equal to n radical 2. So what does that tell me n is?
7.
N has got to be 7 through that algebra, right? We can either divide both sides by radical 2 or just say that visually n has to be 7 to make the left side equal to the right side. So n is 7. So if n is 7, that would make that distance 7 and that distance 7, right?
Yes.
Do those two distances correlate to C and A in my picture? Does that make sense to everybody? So now, by working in that triangle, have we kind of bridged the gap or allowed us to work now inside the blue one? And what kind of triangle is the blue one? Okay. That's the 30-degree angle. That's the 60. That's the 90. What's always across from 30? In, right? What's the hypotenuse always going to be? 2 in. And then the side across from 60 always in radical 3. So now, looking at this picture, if I put the blue one on top of the dark blue one here, that number right there matches up to what? Matches up to n, doesn't it? So in the 30, 60, 90, that is my n value. That's my smallest segment. So that's 7. So what is 2 in? 14. Does everybody see that that would match up to B when I put those back on top of one another? And now what would be this segment right here? 7 radical 3. Does everybody see that matches up to D? Does that make sense? Okay, I'm going to take this one step further. Okay, because this is what we're going to have to do when we start talking about areas. My question to you is, how long is that distance right there? How would you write that distance? Or what is the process that you would go through? You would just add those things, right? You would take 7 plus 7 radical 3, right? 7 plus 7 radical 3. Can I simplify that? Can I combine those? Can I actually? So that is implied addition right there. Meaning I don't have a sum written up there. I just have instructions for you to take 7 and add to it 7 radical 3, right? Can I actually do that addition and find a sum? What do you think that sum is going to be? Any guesses? Okay, so the number one guess is 14 radical 3. Would you guys agree with that? Are we kind of on the fence, though? Are you 100% behind that answer, 14 radical 3? Okay, well, some people are, some people aren't, okay? So here's the idea. If I know that answer, that length is going to be 7 plus 7 root 3, right? If I am uncertain of whether it should be simplified to 14 radical 3, what could I do? Could I type 14 root 3 in? And if they're the same, what number should I get back here?
It's not the same because radical 3 is like a variable. So if you have 7, 7.
Yes. Good. Okay? So what Sam is saying, this is the simplified version. Okay? I get a lot of people to want to make that 14 radical 3. But the argument that Sam is making is that is like 7 plus 7x. Right?
Yeah.
Where x is a variable, right?
Yeah.
X just stands in for a number, right? Could that number be radical 3? It absolutely could be. So if that number was, if we just take radical 3 and replace it with x, would you ever take 7 plus 7x and make it 14x? No, you will leave it 7 plus 7x, right? If I have, think about it this way, 7 radical 3, what does that mean? Or 7x, what does that mean? It means I have radical 3 plus 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 radical 3. I mean, I got 6 of them plus 1 more radical 3. That's what 7 radical 3 means, right? Well, if I put 7 plus that, is there any way that that's going to turn into 14 radical 3s? Does that make sense to everybody? That has to just be the only thing that I have there that are like objects are the radical 3s. So it's just 7 plus 7 radical 3. Okay? When we're adding radicals, let's say I had like 2 radical 3 plus 4 radical 3s. Anybody know how I rewrite that? Because that does get simplified. That's 6 radical 3. If I wrote 2 radical 3 out, it'd be radical 3 plus radical 3, right? If I wrote 4 radical 3 out, it's radical 3 plus radical 3 plus radical 3 plus radical 3. Add all those up, I got 6 of them, right?
Yeah.
Another way of approaching that is, what do they have in common? Do they both have a radical 3 in common? If I factor that out, I would have something that looks like that, right? What's 2 plus 4?
6.
6. So I have radical 3 times 6, and usually we write that as 6 radical 3. So when you're adding radicals or subtracting them, the rule is, if the radicands are the same, you add the numbers out front. If the radicands are different, you do nothing with them. So if I have 2 radical 3 plus 4 radical 2, I do nothing with those because they're not like terms. That's like saying 2x plus 4y. You can't do anything with that, right? So what Sam said, hopefully, did you have Mr. Hur last year? Did he explain that like the radicals are like a variable? Treat them that way. That is perfectly fine. Okay? With addition and subtraction, that's a very, very good idea to kind of commit to memory because we just can't combine unlike things. Okay? Just have any other questions? Anything else on there kids want to talk about? Briefly, we got about 4 minutes here. That assignment, the 8.2, the first one, is due tonight. Okay, that was given on Tuesday. I gave you a lot more time on that than I normally do and wanted to, but because of the cancellation and all that kind of stuff, I think it is best to give you a little bit more time on that. Usually with that assignment, give it on Tuesday, it's due on Wednesday. And then on Wednesday, I give 8.2, the second part with the 30, 60, 90s, and that's due on Thursday. Okay? Now, the 30, 60, 90 one, that's not due till like March 6th. And that's a stupid date, but that's the 2 weeks of school that we get because of blizzard bags, okay? So I'm gonna abide by the law. I'm not going to make it due tomorrow or anything like that. But make sure that you get that done. Don't wait till the 6th to do that, okay? Because when we start talking Monday about 8.3, we're going to use some of this stuff. So it's good to be exposing yourself to the practice examples before we start building upon it, okay? Somebody in the last, or I guess 7th period yesterday asked me, is there a template for a 40, 50, 90? Is there a template for a 31, 59, 90? Okay? And there are. But it's SOHCAHTOA. It's sine, cosine, and tangent. That's how we're going to use trigonometry to find missing sides of other triangles that are not 30, 60, 90, 45, 45, 90. Okay? It's a little bit longer of a process, but it's the only other way that we can find distances in triangles where I know one value. Is that all right? And we'll start that trigonometry aspect of the course on Monday, 8.3 on Monday. So no new homework over the weekend. There isn't, that I told you yesterday that I sent out an email as a radical assignment due next Thursday. It's just practice. It's like 20 questions, just practicing simplifying radicals, adding them, multiplying, dividing them, that kind of stuff. Do 4 or 5 questions a night, and you should be fine with that. Do you have a question?
I did it right here. You put it this. And I put 4.7.
I bet they're going to, you put 4.7 in, put 4.6 in. I bet this is that rounding situation that they're, yep. So you're 4.7 fast or something like that. If you get 4.7 and it counts it wrong, just let me know and I'll go back and give you credit for it. That's just a rounding issue. Yes.
Yeah, I don't.
Yep.
Wait, am I allowed to do college algebra?
No.
Pardon the interruption, but with the following